Hey, good afternoon. My name is Teague, and I'm an SRE at Greenlight.
And my name's Gabby. I am a software engineer at Greenlight.
Today, we'll be sharing our story of how we made observability ownership practical for every developer. But first things first, Gabby, what is Greenlight?
Greenlight is a fintech company and was founded to shine a light on the world of money for families, with a goal to help parents raise financially smart kids and to empower families to navigate life together. We have a suite of services. We both market directly in our mobile app, as well as provide to other companies via SDKs and APIs. Some of the features you can find in our app include support for a kid's debit card with spend controls. Kids can make their own savings goals, and parents can assign their kids chores to track and complete in the app. Additionally, all of our family members can invest in the stock market, and well, there's plenty of other features available. Some quick stats on where Greenlight is today. We currently support over 6 million parents and kids, and we have helped them invest over $70 million. We've helped them put hundreds of millions of dollars in family savings as well. Behind the scenes, we, the engineers, develop and maintain over 150 microservices and counting as we continue to expand our service catalog every day. This little graphic represents all of our active services that have been deployed in all of our environments, from dev, QA, staging, prod. And as an engineer, I'm assigned a subset of these services to develop and maintain.
Yeah. And SREs, on the other hand, oversee the operation of all these services in production. We are responsible for enabling our engineers to ensure their services are reliable and observable. As our SRE team is just a handful of people, we do not engage in the hands-on operation of all of these services, but instead are a resource to our engineers, providing monitoring and best practices and tooling.
To give you an idea of how things work, here you have the meat and potatoes of my day. You'll see my dev pipeline, where I'm writing a new feature in what is likely a Node or Kotlin service. And then I'm going to test it, build it out in my CI pipeline, and eventually deploy it to dev, stage, QA, and finally prod. You'll notice there's no monitor provisioning included in my dev pipeline here. It's because it used to be an independent process.
Right, so our monitor definitions used to exist in an entirely separate repo. To support production operations, our engineers were encouraged to either configure their monitors directly in the Datadog UI or use a Terraform repo as well. Those of us on the SRE team developed and maintained a common set of monitoring best practices as a Terraform module, like the one shown here. This example, let's go back one slide, thanks. This example would be for an endpoint get savings account balance, where the developer configured this monitor to only alert when the endpoint received more than 10 requests and the percentage of those requests was above 10%. The development workflow is shown in the graphic above. Developers had used this repo to define Datadog resources in Terraform. Once they merged their changes, those Datadog monitors would be created in each of our operational environments from a GitHub action. The beginning of our observability journey, this was an effective approach because we could maintain monitoring best practices in Datadog UI, and also would be tagged to review any changes that went into this monitoring repo. So here, you can see how the monitoring pipeline existed near, but not fully integrated into our development pipeline. We did have some wins with this approach though, like defining our monitors as code, which is always good practice. But as we scaled our engineering teams, we began to notice some growing pains when maintaining these two separate processes. Our typical involvement with the monitoring pipeline transitioned from managing the Terraform repo to really just fielding common questions that didn't really have any common answers. So to demonstrate this, Gabby's gonna walk through a typical day in the life of a Greenlight developer, circa 2021.
Welcome back to the developer point of view. Here we have an example service called Account Ledger, and I'm gonna need to get it into prod yesterday. You'll see a path definition for a new endpoint called Get Savings Account Balance, which is one of the more recently added features. Let's make a new PR for this endpoint, and what do you know? It's passing all my GitHub actions. Perfect. It's also been approved. I am good to merge. I'm going to deploy it to some of my lower environments for testing, and again, miraculously, it's passing all tests, and I'm good to try and get it into prod now. But because this is a new service and prod changes are risky, I need to check with SRE and get the green light from them first. So I'm gonna ping them and say, hey team, I'm getting ready to deploy this new service into prod. Testing's going great. I've got the green light from my manager. Do I have your final approval?
Sure, let me take a look. So yeah, without any endpoint monitors or any infrastructure monitors or any operational dashboards, I can't really give you the go-ahead to production. But here's some Confluence pages that we've written up that describe some of our best practices.
Cool. So now I have a little homework, some light reading to do, and I think I have an idea of what my monitors need to look like, but I have no idea how to configure them. Hey, so how do I actually get these monitors configured into my service?
Right, so we can either do it in the Datadog UI, or we have this Terraform repo that you can use to define your monitors.
Great, let me take a look. How do I write this Terraform? I'm normally in Node or Kotlin, maybe YAML, but I'm never touching Terraform. Can you help me out with this?
Yeah, let's put some time on the calendar. I can talk you through some of the Terraform.
Counter's amazing. So we get the new monitor configs written and I put together a PR, but ultimately this repo is owned by SRE, so I need their approval to get it merged and deployed. Hey, before that, I actually don't know if it's gonna work. So when writing these monitors, Connor, Terraform doesn't have unit tests. How do I know that these are gonna work?
So I think in a perfect world, we could deploy all these to lowers first, but since we need to deploy to prod today, we can just do it all together.
Great. Now I need his approval. Hey, Connor, can you review my PR so I can get it merged? Also, can you look over my service and make sure I don't have any gaps in my coverage?
Yeah, I'll take a look, make sure all your infra monitors are set up appropriately and everything's configured correctly in Datadog.
Great. Now that's all done, I have SRE approval, I can resume getting this new service into prod. So it's all the new monitors are all deployed to lowers and finally into prod. Hopefully this looks familiar. It is the SLO with a burn rate monitor that we've been talking about.
Nice. So this pattern of development was okay for a little while, but as the size of our engineering team grew, it was no longer really an effective way to manage our observability and production operations. So in the spring of 2021, while we were preparing for a hackathon, SRE team got together and determined that these were the 3 most common questions that we were hearing with relation to creating effective monitors. 1, what are some best practices to monitor my code? 2, how do I write this Terraform? And 3, how do I know that these monitors are accurate? So to answer these questions, we made Crosswalk. Crosswalk is a hackathon project turned production-grade monitoring development framework. Crosswalk's purpose is to provide an as-code solution to defining observability resources that follow our software development lifecycle. In short, Crosswalk was our way to show engineers the clear path to production. So Crosswalk consists of 2 main components. The first component is the Crosswalk library. Crosswalk library is a node package that defines a set of Crosswalk resources. These defined resources include SLO definition with proper burn rate monitors, useful service dashboard templates, and more. As a basic example, we can explore the SLO definitions in this library. When a developer creates an SLO, they can choose to import a Crosswalk definitions like the one you see on the left. Take the SLO burn rate monitor, for example. By adding a definition for the error budget for a specific time window, Crosswalk will automatically import the definition of a burn rate monitor and create the proper burn rates. This will ensure that they're alerted before they breach their defined error budget. Also included in the library are other monitor definitions for our common deployment patterns. As you can see, this includes Kubernetes pod restart monitors, no healthy upstream monitors, rollout pause monitors, and even more. So the ability to develop and maintain these monitor definitions as a node library has enabled our SRE team to develop, verify, and maintain these definitions just like any other piece of production-grade software. We're now able to write tests to verify the validity and accuracy of our defined observability resources. So the second part is what we call the Crosswalk server. The Crosswalk server is a node service deployed to our operations Kubernetes cluster in the same way as our other backend services. Its main purpose is to serve traffic on a sync endpoint. Upon receipt of a sync request, Crosswalk will perform one of two actions. This comes from a pull request. Crosswalk will validate those changes, compiling the service definitions against that Crosswalk library. It'll determine and display the differences between the desired state and the current state. So if the request is from a deployment event, Crosswalk will update the monitoring configuration for that service based on the environment and the version that's been deployed. If Crosswalk determines that this is the first deployment event, it'll also automatically configure those infrastructure-related monitors. So now to put it all together. Starting on the top left, we have completed deploying a service using Argo CD. Argo controller will send a deployment event to the Crosswalk sync endpoint. Within this deployment event, the Crosswalk will be provided the service name, the version, and the environment. And with these parameters, it'll begin a sync. So first, it will clone the service repository at the version that has been requested. This will effectively download all of the service-specific Crosswalk configuration, such as the SLOs and dashboards. So after this, Crosswalk server performs an npm install on the latest version of the Crosswalk library. And we're always pulling the latest version of that library to ensure our engineering teams have the most up-to-date standards for their Crosswalk resources. And third, once the Crosswalk server has compiled the definitions against the Crosswalk library, it will reach out to Datadog and reconcile those differences that it's about to make. With that, the sync process is complete, and we're ready to operate our service in production. So let's revisit those common questions that made us create Crosswalk in the first place. Number one, what are some best practices to monitor my code? Now, we're able to point our developers to the Crosswalk library as it's an easily understood node package. Two, how do I write this Terraform? So since our Crosswalk definitions are written in Typescript, not Terraform, our developers already know how to write the code to define their monitors. And three, how do I know if these monitors are accurate? Our engineers are now able to validate in every pull request to understand what changes will be made before making them, and they're also able to test those in lower environments before promoting them into prod. So once we finished implementing Crosswalk, the development and observability pipelines were combined. Now our developers can create their monitors alongside the features they wish to observe. Once they've confidently verified their changes during continuous integration testing, they can proceed to deploy their services. Now, Gabby's going to show us a day in the life of a Greenlight developer using Crosswalk.
Okay, let's walk through this new service again. We have the same example service called Account Ledger that I needed to get into prod yesterday, and you see the same new endpoint for Get Savings Account Balance. While creating the service, we're going to create a directory called Observability, inside which we will store all of our Crosswalk definitions in one of the following folders: flows, monitors, or SLOs. Within the SLOs folder, we're going to define an SLO and a burn rate monitor for the Get Savings Account Balance endpoint. On the bottom, you're going to see the SLO burn rate monitor, which I'm passing two different parameters. The first is the SLO definition, which you can see is defined above as an express success rate SLO. This is from the Crosswalk library, and it already knows how to work with an express service. It's going to understand how to query for the operation name of an HTTP endpoint within Datadog, and all I have to do is provide some basic information. I'm going to give it the method, I'm going to send it the path, and I'm going to give it a target success rate over us. The target SLA will define my target success rate over a set time window. Here is 97.99% over a 30-day window. I'm also going to give it some acceptable success status codes, like 400 and 404. To create the burn rate monitor, I pass the express success rate SLO and the desired alert priority into the SLO burn rate monitor I've imported from Crosswalk. Just like that, I'm done with the new feature and the Crosswalk config, and I'm ready to make my PR. As I go through this service and add monitors, I'm going to validate them in each PR. Within the PR, I can add a comment that says /crosswalk run. And Crosswalk does a diff, validates my configuration, and lists out the changes. I can review what changes I've made, and if they pass inspection, my PR is good to go. With all the validation checks passing, I'm good to merge and deploy these changes to lower environments for testing. As I deploy to each environment, Crosswalk will create the related monitors, and I can ensure that as I simulate errors, the burn rate monitor is picking up those errors and responding as I expect. Don't worry, Crosswalk will know that this is a lower environment and not create an incident. Now that I'm ready to go to prod, I can once again reach out to SRE and verify that my service has the green light. Hey, SRE, I have this new service that needs to go to prod. Do I have your approval?
Sure, let's take a look. So first off, how are your monitors coming?
Well, good actually. I added Crosswalk and defined my new endpoint monitors. When I look at Datadog, I see my infrastructure monitors are up, and my endpoint monitors are tracking requests. And finally, there's operational dashboards available to me.
Awesome, and that looks great. Go ahead to prod.
Great, just like that, I can deploy to prod. Once again, you can see my get savings account balance endpoint monitor is up and running in Datadog.
So as you have noticed, Process has made the developer and SRE team a lot more efficient when creating and defining their monitors. Outside improving just the development experience, Crosswalk has also helped to improve our production operations. Through the use of a common library of monitors, Crosswalk has provided us a familiar view into our observability patterns that are easily recognized by our on-call engineers. This has reduced the learning curve for any engineer that's responding to our production incidents, allowing us to effectively mitigate customer impact. So another important aspect of production operations at Greenlight is the creation and use of flow documentation. So as defined, a flow is a description detailing the path a user will take in the Greenlight app to complete a task. So at Greenlight, we started to find this flow documentation just in Confluence. Within a flow, there may be multiple endpoints that together all provide functionality required to complete a specific set of user actions. Defining these flows has proven to be a beneficial pattern for understanding the inner workings of our platform. Additionally, our engineers were able to reference these flow documents during incident response to debug and mitigate issues experienced by our customers. So as we were building Crosswalk, we realized we had the opportunity to enhance the way we manage flows. So within the Crosswalk library, we provided a framework for engineers to define specific flows that will be used to build operational dashboards. The Crosswalk definitions of flows include a list of related endpoint SLOs and any relevant documentation. With this list of endpoints, Crosswalk will also generate a composite SLO, which displays the overall performance of the flow based on the combined performance of the relevant endpoints. Crosswalk will also compile any necessary documentation provided in a README format and display that in the Datadog dashboard. Additionally, if a sequence diagram is provided, Crosswalk will compile that and display that as well in the Datadog dashboard. So these dashboards have proven to be an invaluable tool for engineers as they work to mitigate the issues to respond to an incident, or even to look to gain a better understanding of our systems. So now, Gabby is going to show us day 2 in the life of a Greenlight developer who uses Crosswalk.
We'll call our new account ledger service with the get savings account balance endpoint. That endpoint is part of a flow called transfer to savings account. Basically, when a user goes to transfer funds into a savings account, they'll hit several different endpoints. They'll do one to fetch available funding accounts, one to verify a savings account exists, one to verify the balances of those funding accounts. And once they've selected a funding account and an amount, they're going to have to move those funds. In Crosswalk, we define a flow by creating an array with all the related endpoint SLOs and a path to any related documentation that I might have. That's pretty much all you have to do. And just like that, I deploy this. After deploying those updates to Crosswalk, this dashboard is what gets created in Datadog. On the left is our flow documentation with the description, customer impact, business impact, and the sequence diagram below. On the right, we have our SLO summaries. The top row is a composite SLO for all the endpoints, and for comparison, we'll have the previous month and the past hour. Below that, we're going to have the SLOs for all of the individual endpoints. Then we have the time series view, we have the success rate over the past hour, and the count of successful hits. Let's demonstrate how this dashboard gets used. Let's Friday, 2 p.m., CS gets a call from a customer reporting issues moving money to their savings account. CS is going to forward that report to my team, and I'm going to go first step to this dashboard. Dashboard's indicating that the check for savings account endpoint has seen some failures in the past 2 hours. So I'm going to start there. The SLO can link me to traces. The traces can link me to logs, and those logs can tell me enough to decide that this is an independent incident. CS can work with that customer because it looks like their savings account is inactive and help them to reactivate it. This dashboard helped diagnose the point of failure quickly, and had it escalated into an incident, we would have had the proper engineering context to mitigate that.
Great. Thanks, Gabby. So with Crosswalk, developers are empowered to own the observability of their services, and it's also made it easier to operate their service in production. So we've made this ownership more practical by merging the monitoring pipeline into our development pipeline, allowing developers to define observability within their service repos, reducing their context switching, creating a node library that adheres to observability best practices and can quickly be understood and leveraged to monitor any service the developer is currently building. And it creates easy-to-use dashboards to reduce investigation time during incidents.
We've come here today to show you this in hopes that you can learn from the evolution of our observability journey and how valuable making monitoring a part of your everyday engineering workflow can be. Greenlight has embraced the use of Crosswalk, and Crosswalk now defines 94% of our production monitors. In this adoption, we've seen a reduction in PRs to deploy and monitor new features by 50%. We have also eliminated the need for SRE to review PRs for any of our 150 services monitoring needs.
Great. So using our example, we encourage you to analyze the observability pipelines that you're working with to currently see what frictions you can eliminate for your own developers as you look forward to fostering a better observability culture for your entire team. Finally, we'd like to ask the age-old question. How did the developer cross the road? They used Crosswalk. Thank you all so much for coming. Thanks to be online. We have attached our emails if you'd reach out directly to us. And at this point, we'll open the floor.
Thank you, Connor and Gabby. Great talk. If you have questions, please make your way to one of these microphones in the aisles.
Hi. What was the adoption like for your developers for Crosswalk?
Yeah, so because this was built out of a hackathon, there was a lot of excitement around Crosswalk already. That definitely helped out that initial push of saying, hey, this is something new and exciting that we're able to build that's going to make our developers' lives easier. From an SREs perspective, it was not as fast as I wish it would have been, but I don't think any adoption is. But really working with our development teams and showing the power that is our development process using Crosswalk, I'd like to say that it caught on. Gabby?
Once we were shown one example, it was pretty easy to duplicate that across endpoints as we were making them. So they made it easy on us.
Where can we get it? Or do you have any advice on how to build it ourselves?
Yeah, so where can you get it? I can't really offer that to you, but we're investigating different opportunities of blog posts of how we built the thing and kind of our best practices tips. Datadog's APIs have a plethora of information that you can use to build out these practices on your own. I would say build it small first, pick a couple different use cases, and then see how you can expand.
I presume this is predicated upon the metrics. I'm already going to Datadog and being part of those instrumentation libraries. I see this being like definition within the platform, but I presume that this is also, again, predicated upon those observability metrics being emitted to the platform as like that already happening. Is that correct?
Yes. Yeah.
As a SRE team, how do you guys audit these monitors? Like, for example, if someone changed the SLO warning to, lower the value, let's say, right? How do you guys catch this in this process?
Yeah, that's a really good question. It's difficult to audit specific error rates and burn rates and things like that. But we do have a set of auditing tools that we have for our PRs. And so whenever we do deploy to production, since we can tell what changes are going to be made observability-wise, a part of that approval process is SREs seeing the different rates that will be changed for your monitors. And we're able to either approve or have that discussion to see, is this because it's too noisy or because you're having difficulty in your endpoint? So,
Thank you. Yeah.
sure.
Hey, can y'all talk a little bit about the timeline for development of Crosswalk from the SRE team and what it looked like for timeline for adoption?
Sure. I can talk development. Maybe you can talk more about how long it took to adopt it. Since it was a hackathon, that's super short. I think it was probably 3 days to get that initial push of this is how Crosswalk should work. This is the initial idea, POC. Actually building the tool took most likely a quarter, I'm trying to remember if it was quarter and a half, to actually build and get the Crosswalk server up and running and the library kind of laid flat so we're able to utilize it across the organization.
When I got the ticket on my board, it really didn't take long to get the directory up and running and some endpoint monitors on a per service basis, probably a sprint. Yeah, it really didn't take that long to get into an individual service.
Perfect. Thanks, y'all.
Hey, quick question. So for the library, are you directly using the Typescript to create Datadog resources through the Datadog API, or do you still maintain like Terraform under the hood?
So we are using the direct Datadog API and the TypeScript classes that are provided.
Okay. Mm-hmm. Thank you.
Makes things a lot easier, definitely.
Yeah, so when sort of setting up like, error rate monitors for like your software engineers, did you ever find that they sort of maybe had like an excess amount of errors, and then you talked about like, oh, those errors are fine, and so like makes the metrics look bad? In your experience, is that sort of thing something you try to push back on, or is it something you just accept, like you're the engineer, you define your SLOs, and if you want to have more errors, you can?
Yeah. So that's whenever Gabby was talking through how we define those burn rate SLOs, that's why we added in the success rate or the success code array. And so basically you can have that good engineering conversation and say, okay, do you want to be told for every 403, every 400, every 404, if it's a bad request or it's not really valid? Maybe you shouldn't be alerting. That's not necessarily an error. So if nothing else, it's a really good starting off point to have those discussions to say, hey, let's make sure we're reporting these errors appropriately and not alert to non-errored.
Yeah, it looked like you guys were using like a monitor per service, or sorry, a monitor per environment. Can you explain why you did that rather than like creating one and using facets to alert?
Sure, I'll give the SRE perspective, and then maybe Abby can expand more on the developer. So from SRE perspective, it may be a little bit easier to maintain one monitor faceted by environment. Unfortunately, whenever that comes in, you don't really know, is this something that I need to act on right now? Is this a flaky, strange endpoint in dev environment and that I don't really need to address? So it could cause some false positives or some false I wake up at 2 in the morning because my dev monitor is firing. So I'd like to think that it's helpful to have them all separated out so you can set individual priorities so you get paged individually. I don't know if you have an experience around that.
I just have to double down on that. It's easier to independently configure them for separate environments, and maybe prod's a little louder than my dev and QA environments.
Thank you.
Thanks.
So how does Crosswalk manage the state of the alerts, as in someone changing something in Datadog UI versus the configuration file within the source code?
Sure. So to manage the state, we actually are just doing a live diff on those resources. So downloads can use either a TypeScript class. Before in the hackathon, we were just using JSON to see what was different. And so all that's just live performed during that sync process, not really using a state file or things like that the normal Terraform would use.
Gotcha. Thank you.
Thanks.
Hey guys, nice talk. Really enjoyed it. Curious if you've measured some of the
perhaps some of the delivery velocity improvements or time savings as a result of implementing?
So broad strokes, I think that the main metrics that we're able to pull is really more of our resource observability coverage. Before using Crosswalk, it was, okay, hey, let's deploy this service. Okay, I have these new endpoints out there. And then it was probably like a week later saying like, hey, SRE, like you should probably monitor these endpoints. Now with using Crosswalk, all of that is a part of the development pipeline. And so those gaps really don't happen as much. I don't have a number off the top of my head, but last time that I checked, it was above 85 to 90% of all of our resources are covered by a monitor, which gives us really high confidence that we're going to be notified if something goes wrong. That's our main metric of how we measured how well Crosswalk is performing and operating for our teams.
Got it. Yeah, from the coverage perspective, from the dev side, are you seeing faster PR approvals, faster flow through the SDLC?
Oh yeah, it's a lot easier to get monitors up and running and for him to talk me into putting monitors on all my endpoints when it's just a few types, yeah.
Awesome. No, cool stuff, guys. Thank you.
Thank you.
Hi, I guess adding on to that, is there a way that you guys ensure that software engineers remember to add Crosswalk resources when they set up new endpoints?
Yeah, so kind of on that same point of the observability coverage, we have another system that's similar to like a service scorecards. Datadog has a similar offering that we'll actually check to make sure that our services have that observability coverage before they deploy. And so if they're pushing a new version that may not have observability on those new resources, it'll actually flag and say, hey, in stage, you're not monitoring these endpoints. You need to get those monitors before we're able to go to prod.
Awesome. Thank you.
Thanks.
All right, last call for questions. Okay then. Well, Gabby, Connor, thank you again for a great talk. And one more round of applause, please.